So let's go ahead and give ourselves a more difficult type of problem. Let's go ahead and try pulleys in combination. And what we mean by pulleys in combination is we're literally going to combine pulleys together in one system. And so let's draw ourselves a similar example from the one we did in the last video. And so we still have our legally safe knockoff space droid coming down. But this time let's add a fixed pulley off to the side. And so that way coming off this droid, we can have the rope tie off on the roof, wrap around this movable pulley, but then it can wrap around this fixed pulley as well, so I don't have to be up high. I can be down low over here, pulling down on this rope with my force effort, while my force resistance is going up. And so we'll keep our force resistance as 150 pounds. And so how to figure out how this system sort of works, how the force resistance affects the force effort and vice versa, you kind of have to look at it in halves. And if you look at it in halves, if you cut it and just look at the movable pulley, you can see that each one of these strands here are sort of dividing the force resistance in half. Each one of these strands will support half of the force resistance. And so we'll have 75 pounds pulling up on this side. And we'll have 75 pounds pulling up on this side.
And then if we look at the other half of the system, so we cut out the movable pulley
that we just divided into, and we just look at the other side, well, that's essentially just a fixed pulley having to fight this 75-pound force. And so on this half of the system, there is no mechanical advantage. The force effort is just 75 pounds. And so to calculate the mechanical advantage in this system, we would do the exact same thing we did in our last example. We would use our AMA-free equation. And the only real difference here in this system and the last one is now we're pulling down instead of pulling up. But other than that, it's the exact same. Its FR is 150 pounds still, and FE is still 75 pounds. And so the actual mechanical advantage, or the AMA, is just 2.
And since we know that assuming an ideal effort force, the AMA equals the IMA,
then we can assume the IMA equals 2 as well. And so you can just kind of look at it to figure it out, to see what the force effort would be and see what the mechanical advantage would be. And so let's look at another simple example. And this time let's go ahead and just have a series of fixed pulleys. So no movable pulleys, just several fixed pulleys working in combination. And let's say we're going to lift up a 50-pound force resistance. And let's go ahead and run a rope through this system. So we have it going around this first pulley, then we have it going around this second pulley, and then let's go ahead and have it, of course, go around the third pulley, obviously. And let's say we're pulling down here with a force effort, FE. Well, unlike in the first example, in this example we only have one strand lifting up and supporting this 50 pounds. And so that means to pull this up, this strand is pulling down with that same 50 pounds. And this strand is pulling up on this strand over here with that same 50 pounds. And that means my force effort is pulling this up with that same 50 pounds, which means my force effort is equal to that. And that makes sense because these are just fixed pulleys. This is a fixed pulley here, so this is 50 over 50. And this is another fixed pulley with a mechanical advantage of 1, which is just 50 over 50. And this is as well over here. So in this entire system, we can say that our mechanical advantage, to figure it out, we would use this exact same formula over here that we already used, this AMA-free equation. And what we get is 50 pounds for our force resistance, and we get 50 pounds for our force effort. And of course, 50 divided by 50 and pounds divided by pounds all cancel out. What we're left with in this system is a mechanical advantage of 1. And of course, that's our actual mechanical advantage.
and we're going to assume an ideal effort force, so we can set that equal to our ideal mechanical advantage, so that will also be 1.
And so the idea behind this video is being able to look at these pulley systems and sort of figure out what the mechanical advantage is just by looking how the weight is distributed. But I want to see if I can make it even easier. So let's look at the number of strands in each system. In this system on the left, we have 3 strands, and in this system on the right, we have 4. But then if we look further, we can say, well, this one has 3 strands, but only 2 of them are actually supporting FR. And this one, even though we have 4 strands, only 1 of them is supporting FR. And so let's go ahead and write that out for ourselves. Let's say there are, in the left one, there are 3 strands in total, but only 2 of them support FR. So only 2 strands support FR. And similarly, on the right, we have 4 strands in total, but only 1 is supporting FR. So only 1 strand is supporting FR. And so this is what I want you to take away from this video, these words supporting. If you look how many strands support the resistance, it's always equal to your IMA in a pulley. And this is the rule for all pulleys. So let's go ahead and write this out. So in pulleys, the IMA equals the number of supporting strands. And I can't stress this enough, this is true for all pulleys. And that makes calculating the IMA for pulleys incredibly easy. You just calculate, you just count the number of supporting strands. And given this rule, and the rules we already know about what makes a fixed pulley, fixed pulleys always have an IMA equal to 1. And since we already know what movable pulleys look like, and they always have the same system, a movable pulley is always, or always has, an IMA equal to 2. And that's a rule you can always follow, because if you look, let's actually cut it out right over here. If you look at what is a movable pulley always has 2 strands, which means 2 supporting strands, which means an IMA of 2. Versus a fixed pulley, if we were to cut out the other side and just have the fixed pulley, a fixed pulley always has
1 supporting strand, which means it always has an IMA of 1.
And then pulleys in combination, where you have to kind of count the number of supporting strands to figure out what the IMA is. But hopefully that makes calculating the IMA of any pulley super, super simple.